All right, this video is about the z-score. So now the definition of a z-score is how many standard deviations away from the mean a data point is. So a lot of definitions going on there. First of all, data point, that's just any piece of our data, like this guy, that's the x, anything. So back to our other example, these are branch managers. So like we would have this whole list of all the branch managers that we went out and got collected, and there might be like a 35-year-old branch manager, for instance. So that's like here. So here's a sample question. So in our data somewhere there's a 35. And now we haven't built our normal curve here. Let's say we don't have time to build this out. But we still want to know, like, how normal is that? Is it weird to be 35 years old and a branch manager? Is that too old, too young? Like, where does that fall, right? Where is it in relation to our mean? So what we could do is we could run it through this z-score formula over here. So we take the data point. So we'll just do that over here. So it's like question A. Is a 35-year-old branch manager too old for their position? So let's see. We'll say 35 years old. That's the data point. We're going to take away our mean from our previous problem. That was 32 and a half years old. We're going to divide this by our standard deviation, so 2.3. Just in your calculator, make sure you do it step by step. If you're using not like a TI or something that doesn't understand order of operations, just go slow. So I would do 35, subtract 32.5 and hit enter, and then divide that by 2.3. So I get an answer here of 1.08, 1.08, let's call it 7. We'll round it up right there. So what we're saying here is that this data point, 35 years old, is 1 and a little baby bit more standard deviations more than the mean. So here's our mean, remember. Here's 1 standard deviation, so it's saying it's 1 and barely any more. So it falls like right there. Well, of course it does. Remember, we already built this curve. Well, 35 is right next to 34.8, so it makes sense. But remember, this would be like without using the curve. So we found this z-score and we say, hey, it's within almost 1 standard deviation of the mean, so that's very normal. That's where most of our data should fall, right? So then our answer to this is no. No, this is not unnormal. Most branch managers are this old. So then another type of question we might have to answer here is what age branch manager would have a z-score of 1.5? So again, 1.5 in the positive, because it didn't say subtract, positive 1.5 means you start at your mean, you go over 1 plus another 0.5, so we're talking about something that goes right here, right? But in our formula here, we're just going to have to do a little bit of algebra. So we have 1.5 is our z-score. We're now looking for that data, that x that made that, but we are stuck with the same mean, and we are stuck with the same standard deviation. So I'm going to multiply both sides here to get the 2.3 gone. And then when I do that, so I get 1.5 times 2.3, that is going to make 3.45, which is then equal to the x minus 32.5. Then I'm going to add 32.5 to both sides, and I'm going to find that that's 35. So this answer here is 35.95 years old. So almost 40. So what we're saying then is it's, again, it makes sense because we have our normal curve in front of us, but if we didn't have it, that's how we would find it out using that formula, right? So we would say, yeah, 1.5 standard deviations more than the mean is 35.95 years old. About 40 years old is 1.5 standard deviations more than the mean, right? So that's how we would answer these types of questions. So you need to be able to find a z-score, use this formula. See how I used it both ways? Solve it for the z like we did in the green here to get a z-score, or take a z-score like the purple here